Previously, we looked at haematopoiesis in the various stages of gestation or pregnancy, which includes haematopoiesis occurring in the embryo, which is also known as mesoblastic haematopoiesis. And we also looked at haematopoiesis occurring in the fetus, that is the fetal stage. And in the fetal stage, we understood that this is the stage where the liver and the spleen comes in, and much of the blood cell production is coming from the liver, and that is known as hepatic haematopoiesis. And we also looked at haematopoiesis occurring in the bone marrow, that is from the 6th to the 7th month onwards of the fetal life. The bones begins to form and haematopoiesis begins to occur within the bone marrow. And we indicated that haematopoiesis occurring within the bone marrow is called the myeloid haematopoiesis. In today's lesson, we shall be looking at haematopoiesis in the postnatal and the adult life. It is important to note that haematopoiesis within the liver and then the spleen actually does not happen in the postnatal and adult life. Therefore, in the postnatal and adult life, when there is production of blood cells within the liver and then the spleen, then that becomes pathological. And that usually comes in when there is an excessive demand of blood cells and the bone marrow is unable to meet that demand, and that will result in the resort to the liver and then the spleen to contribute to the production of blood cells. And when that happens, technically the liver and the spleen becomes enlarged in an attempt to support the bone marrow, and that is known as hepatosplenomegaly. That is the enlargement of both the spleen and then the liver. So quickly, let's look at, so we want to look at haematopoiesis within the bone marrow. Once there is blood cell production within the bone marrow, then it presupposes that there are actually hematopoietic stem cells in the bone marrow, as we indicated earlier on. So within the bone marrow are stem cells. So we have stem cells known as hematopoietic stem cells. So we have hematopoietic stem cell. As mentioned earlier on, all hematopoietic stem cells carry a potential or an ability, and the potential of the stem cell must be indicated. And so this hematopoietic stem cell is actually a pluripotent stem cell. So being a pluripotent stem cell, the word part pluri means many. So because this hematopoietic stem cell has many potential, then we can rename this hematopoietic stem cell as a pluripotent hematopoietic stem cell. So this pluripotent hematopoietic stem cell actually becomes the starting stem cell. So this is an unspecialized stem cell or an undifferentiated stem cell. So this particular stem cell will undergo differentiation. So the stem cells undergoes differentiation. So it undergoes differentiation. So it undergoes differentiation to form the myeloid, stem cell, the myeloid stem cell. The myeloid stem cells and the lymphoid stem cell. The lymphoid stem cells. So we have our pluripotent hematopoietic stem cell undergoing differentiation to form the myeloid stem cell and the lymphoid stem cell. This pluripotent hematopoietic stem cell that has just differentiated into the myeloid stem cell and the lymphoid stem cell has just been lost. This means that there is no pluripotent hematopoietic stem cell in the bone marrow. Therefore, this implies that hematopoiesis will come to a halt when the terminally differentiated cells are lost in circulation and we want to start the process of hematopoiesis again, we will not be able to start the hematopoiesis again because the only hematopoietic stem cell has already been used up. This means that for hematopoiesis to continue, anytime we are about to begin the process of hematopoiesis, the pluripotent hematopoietic stem cell must self-renew itself. So this particular stem cell has a self-renewal property to create a daughter pluripotent hematopoietic stem cell. So a copy of the pluripotent hematopoietic stem cell is created before the pluripotent hematopoietic stem cell. One of them will undergo the differentiation to form the myeloid stem cells and the lymphoid stem cell. This is to ensure continuity of the process of hematopoiesis. So these myeloid stem cells and the lymphoid stem cell also actually have potential. They are also stem cells. All these stem cells we are talking about, they are all within the bone marrow. And so these myeloid stem cells and lymphoid stem cells, they have the ability to give rise to more than one class of what? Terminally differentiated cells. And because they have more than one, we say that their potential is many, and many is called multi. So we have a multipotent myeloid stem cell, and we have a multipotent lymphoid stem cell. So we have a multipotent myeloid stem cells and a multipotent lymphoid stem cells. Now, the descendants of the pluripotent hematopoietic stem cells, which are the myeloid stem cells or the lymphoid stem cells, are also called progenitor cells. So we have what we call progenitor. So the descendants are called progenitor. So progenitor cells. So we can call the myeloid stem cell as a myeloid progenitor cell and lymphoid progenitor cells. So the early descendants of the pluripotent hematopoietic stem cells are called progenitor cells. Now, these myeloid stem cells and then the lymphoid stem cells will undergo further differentiation. It is important to note that the process of differentiation is actually sending the cell from the unspecialized state to a more specialized version. So anytime the cells is undergoing differentiation, it is a step closer to becoming a specialized cells. And so these multipotent myeloid stem cells will undergo further differentiation and proliferation, in this case an increase in number. Proliferation means increase in number. So these undergo further differentiation to form what is called, so these are the stem cells that will originate from the myeloid stem cell. So we have the colony forming unit, so we have the colony forming unit, granulocyte, monocyte, eosinophil. Then we have colony forming unit, basophil. We have colony forming unit. So we have colony forming unit, megakaryocyte. So colony forming unit, megakaryocyte. So we have colony forming unit, granulocyte, monocyte, eosinophil colony forming unit. Then we have colony forming unit, basophil, and colony forming unit, megakaryocytes. And all these cells are originating from the myeloid stem cell. So let's look at what comes out from the multipotent lymphoid stem cell or the lymphoid progenitor cells. So the lymphoid progenitor cells will give rise to, so these lymphoid progenitor cells will give rise to T, so we have, this will give rise to T lymphocytes, to give rise to B lymphocytes, and natural killer cells, in other words, NK cells. All these are white blood cells and they originate from the lymphoid stem cell. Notice the name, lymphoid, lymphocytes. So all the lymphocytes originate from the lymphoid stem cell. Now, when we say colony forming unit, a colony, just as in bacteriology, when we say a colony in bacteriology refers to collection of bacterial cells or a group of bacterial cells. In hematology, when it comes to hematopoiesis, the colony as used here refers to a group of or a collection of hematopoietic stem cells. So when we have collection or a group of hematopoietic stem cells together, we call it colony. So colony forming unit, this one is a colony comprising of hematopoietic stem cells, and these are hematopoietic stem cells that will give rise to hematopoietic stem cells of granulocytes are in the colony. Hematopoietic stem cells of monocytes are in this colony. Hematopoietic stem cells of eosinophils are part of the colony. So a collection of hematopoietic stem cells is called a colony forming unit. And so we have this colony forming unit. This means that this cell is actually having potential. So we have multiple potential. So this means this will undergo further differentiation to form colony. This will form colony, undergo further differentiation to form colony forming units, GM, that is granulocyte monocyte colony forming units. And we will have colony forming unit eosinophil. Then we'll have another colony forming unit. So this is called the bust forming unit. The bust forming unit, erythroid. So these are when the colony forming unit granulocyte, monocyte, eosinophil undergoes further differentiation, they will split. So the differentiation of this colony will give rise to colony forming unit granulocyte, monocyte. So the granulocyte and monocyte stem cells are together in a form of a colony, but the eosinophil stem cells are just this. So this is just a single, these are colonies of what? Eosinophil stem cells. So this is more committed to the eosinophil production. And we have bust forming unit erythroid. It also is made up of colonies of erythrocytes, erythroid precursors. So colonies of erythrocyte, but it is in terms of numbers. So this bust forming unit erythroid technically will give rise to what is called the colony forming unit erythroid. The difference between the bust forming unit erythroid and the colony forming unit erythroid. So this is All these ones are colonies, but when we count the number of precursor cells that are in a hematopoietic assay of the bus-forming unit erythroid, it has about, greater than, so the bus-forming unit erythroid has about greater than 200 erythroblasts, whilst the colony-forming unit erythroid, the colonies have about 8 to 200 erythroblasts. So the bus-forming unit actually consists of stem cells that are committed to the production of what? Erythrocytes. Likewise, the colony-forming unit erythroid. But in terms of the erythroblast number, when we do hematopoietic assay, the bus-forming unit erythroid has over or greater than 200 erythroblasts or normoblasts as compared to the colony-forming unit erythroid. So this one has larger number of the erythroid precursors as compared to the colony-forming unit erythroid, which ranges from 8 to 200. Now, this colony-forming unit granulocyte monocyte is actually not committed. So we want to get a more committed colony-forming unit. So this will undergo further differentiation, and we will have our colony-forming unit granulocyte and our colony-forming unit monocyte. So this colony-forming unit granulocytes will now give rise to the terminally differentiated cells. So you notice that this colony-forming unit granulocyte, colony-forming unit monocytes. So colony-forming unit granulocyte will only give rise to granulocyte. But the granulocyte in question here is actually the neutrophils. So we will actually produce neutrophils. In a particular context, granulocyte in the hematology, in a particular context, granulocyte is used to refer to neutrophils, eosinophil, and basophil. In another context, granulocyte is also used to refer to only neutrophil. When it comes to hematology practice, when we run a full blood count test, and in the full blood count report, what we see, when we see granulocyte in a full blood count report actually is referring to neutrophil. So in practice, when clinicians are talking about granulocyte, most often than not, they are referring to neutrophil. And so this colony-forming unit granulocyte will only produce neutrophils alone. This colony-forming unit monocytes will produce only what? Monocytes. So this will give rise to monocytes. So and this will also give rise to what? Eosinophils. So eosinophils will originate from the colony-forming unit eosino, and this will give rise to erythrocytes or RBCs. So notice that these stem cells, colony-forming unit granulocyte, which is giving rise to only one type of cell, this stem cell, the colony-forming unit granulocyte, is said to be a unipotent stem cell. A unipotent stem cell is that stem cell that has only one potential. And so because this colony-forming unit granulocyte can only and will only give rise to the neutrophil, is said to have a uni. Uni means single. So this is also a unipotent stem cell. A unipotent stem cell. These are also unipotent stem cells. And so these unipotent stem cells are actually committed. So we call them committed progenitor cells, or they are committed to the respective terminally differentiated cells. Now, the colony-forming unit megakaryocyte will also give rise to, this will give rise to megakaryocytes. So it will give rise to megakaryocytes. So this will be megakaryocytes. So these are the stem cells and their respective terminally differentiated cells. So I want us to quickly introduce some terminologies with respect to the production of these individuals terminally differentiated cells. I mean the neutrophils, monocytes, eosinophils, erythrocytes or RBCs, megakaryocytes, lymphocytes. So we want to introduce terminologies when it comes to the production of these terminally differentiated cells. Now, recall that we say the surface for production is called poiesis. The surface for production is called poiesis. So if we want to create a terminology for the production of each of these respective terminally differentiated cells, we just need to know which terminally differentiated cell you want to produce. So we want to produce the terminally differentiated cell called neutrophil, and therefore the production of neutrophil will become, so we attach poiesis to the neutrophil, so this will become neutropoiesis. So neutropoiesis simply means the production of neutrophil. Are we producing monocytes? Then we attach poiesis to it, then that becomes monopoiesis. Are we producing eosinophil? Then the production of eosinophil becomes eosinopoiesis. Eosinopoiesis. Are we producing red blood cells? The scientific name for red blood cell is erythrocyte. And therefore, the production of red blood cells will be called, red is called erythro. So that will become erythropoiesis. Then, if we are producing megakaryocytes, then that becomes megakaryopoiesis. Megakaryopoiesis. So megakaryocyte production is known as megakaryopoiesis. Notice that these megakaryocytes is what will give rise to our platelets, and platelets are called thrombocytes. So the terminally differentiated cells is actually thrombocytes and not megakaryocytes, and therefore the production of thrombocytes is known as thrombopoiesis. So whether thrombopoiesis or megakaryopoiesis will mean the production of the platelets. So this and the production of the lymphocytes, whether T lymphocyte, B lymphocyte. So this will be called lymphopoiesis. So we will have lymphopoiesis, which is the production of lymphocytes. So basically these are the terminologies that are used when it comes to the production of these terminally differentiated stem cells. Now, all these stages that I have indicated, right from the pluripotent hematopoietic stem cells up to the respective colony forming unit J, colony forming unit M, colony forming unit erythroid, colony forming unit megakaryocytes, they are all happening inside the bone marrow. In fact, we shall take each of these respective hematopoiesis, each of these respective hematopoiesis, and then elaborate it or expand it into details. So this is actually a summary of the various types of hematopoiesis that will arise from the pluripotent hematopoietic stem cell, and we will also explain and then get the concept as to how the stem cell will be triggered to produce a particular kind of terminally differentiated stem cell, and will not go to a particular direction in producing another terminally differentiated stem cell. So basically this is a tree diagram that refers to the various types of hematopoiesis that will arise from the pluripotent hematopoietic stem cell. In our subsequent lecture, we shall be looking at the erythropoiesis. So we shall take erythropoiesis and delve it into detail. Thank you.